Welcome to the video. Yay, you're here. We're going to learn about naming carboxylic acid derivatives. So, what are carboxylic acid derivatives? They're anything with an acyl group like this and some other thing on it that where the Z is more electronegative than a carbon atom. So, three that are already on page 1 of notes for chapter 22 on the right are esters, carboxylic acids, and amides. The two on the left we're going to focus on more this chapter than we have in the past. Those include acid chlorides, and anhydrides. So, this video is really going to be focused on acid chlorides. And it turns out that with acyclic acid chlorides, we number the carbonyl carbon as position number 1, and then we change the suffix to OYL chloride, oil chloride. So basically that's the exact same thing as carboxylic acids, but instead of oic acid, it's oil chloride. Cyclic is, again, very similar to carboxylic acids. Acid chloride position is number 1, and then we end the name with carbonyl chloride, because there's a carbonyl and a chloride. So carbonyl chloride. So that's how we name them. So let's do the example from the notes now. And this would be a good time to pause the video, whoop, and try and name this one yourself. And actually, I'm going to draw the other one right now too. All right, so we have a couple acid chlorides up here. So now you've already paused the video and tried to name this one yourself. And remember that you will need to use stereochemistry for these different stereocenters. How are we going to name this? Well, we are going to start with the carbonyl carbon as position 1. 1, 2, 3, 4, 5, 6. So we have a 6 carbon chain. So that's hexanoyl chloride. Hex for the 6 carbon long. AN, because there is no alkene or alkyne. Oil chloride to explain the functional group at position 1. Now we have to add in things for the substituents. We have a substituent at the 2 position. It's 2 carbons long, so it's an ethyl group. So that's 2-ethyl. And then we have a methyl group at the 4 position. So it's 4-methyl. So 2-ethyl 4-methyl hexanoyl chloride. Are we done? No, of course not. We still need the stereochemistry. Also, I didn't mention, why did we put ethyl before methyl? Because they're alphabetized. So what about the stereochemistry? So position 2 has this group. That's going to be the first priority because it has the double bond of the oxygen. The second priority is going to be over here. So we'll do first priority, second priority, third priority. Fourth priority is the hydrogen that's not drawn in. So hydrogen's in the back, that's good. Then we go 1 to 2 to 3, that's clockwise. So we would have a 2R. And then we also have a stereocenter position 4. For that stereocenter, this is position 1. This is position 2. It has priority over the methyl group. This is position 3. And then the fourth one is the hydrogen. So again, the hydrogen's in the back, so we don't have to do any manipulation. Then we go 1 to 2, 2 to 3, counterclockwise. So this is S, 4S. So the full name of this would be 2R, 4S, 2-ethyl, 4-methyl, hexanoyl chloride. So that is an acyclic acid chloride. What about a cyclic acid chloride? Well, the acid chloride is position 1. So this is going to be position 1. So now would be a good time for you to pause the video and try to decide how you are going to name this. So boop, paused, spend some time. Now you're going to unpause. Perfect, you did it. This molecule has a mistake that is commonly done by people. So often people want to number counterclockwise around this ring because they want bromine, the lowest numbered substituent, to have the lowest possible number of those 3 substituents. But the rule that is above that rule is to get the lowest numbers, to get the lowest overall numbers for those substituents. So if we number this way around the ring, our substituents are numbered 3, 4, and 6. If we were to number the other way around the ring, our substituents would be 3, 5, and 6. So 3, 4, and 6 is lower than 3, 5, and 6, so that's why we use the black numbering. So I'm going to erase those red numbers. Okay, so this ring has 7 carbons in it, so that's going to be cycloheptane. So cyclo because it's cyclic, hept for the 7, AN because there are no alkenes, cycloheptane. And then we number this like an alkane, like a cycloalkane, and then we just add carbonyl chloride to the end. Cyclohexane, carbonyl chloride. This could have stereochemistry on it. It is not indicated, so we just assume that it is random. So we don't have to worry about the stereochemistry on this one. We do have to put in the substituents, and we're going to alphabetize those. So it would be a 6 bromo, 3 chloro, 4 isopropyl, cyclohexane carbonyl chloride. So that is how acid chlorides are named. So now we're going to move on to naming more things in the future. All right. Hope it was fun.